A survey asked 169 students, what is your height in inches? And this is the data. So all the responses are listed on the left, and the frequency of each response is listed on the right. Now, before we go too deep into this, well, we can notice that a lot of people were 64 inches tall. That's quite a few people. 64 would be 5 feet 4 inches. And the next most popular response was 72 inches, which is exactly 6 feet tall. And then there was a lot of other responses between those two popular values. This is a grouped frequency table. So instead of listing the frequency of each value, that table was just really long and kind of cluttery, hard to look at. I mean, I don't mind having it for my raw data, but this grouped frequency table cleans it up a little bit. And I have 3 different versions here, 3 ways to set up a group frequency table for the data. Let's see if I can zoom in on this a bit. As you calculate the frequency for each class, what questions or concerns do you have? What pros and cons do you notice for the 3 approaches? So 50 to 54, 1 person. 55 to 59, 2 people. Let's confirm that. "55 to 59 had 2 people. Well, yeah, there they are. Those are the 2 people. And then 60 to 64, 60 to 64, we need to add up all these people. So that's why I have this little mark right here. So 5 plus 7 plus 9 plus 8 plus 1 plus 26. Those are all the people we're adding up. We got 56. And you might think this is a really good setup until you get to the data value of 64.5, and then you're like, whoops, that one fell between the cracks. We don't know whether it should go in this category or in this category. This one's okay until we realize there are gaps between the classes or intervals. So these are the classes, and I don't like that there's a gap. So I might come up with the following system. Instead of saying 50 to 54, I say 50 to 54.99. And that way I feel like I'm going to capture those decimals. Like the 64.5 would be in this category. So there would be one more value in there. So that goes up to 57 because we captured that data value in this category. I find this a little annoying though, because writing 0.99, it's cluttery, and it's still conceivable that you get a data value that would slip between the cracks. 54.993 would still not be covered. So then I go to the following solution, which is just to say 50 to 55, 55 to 60, 60 to 65, etc. And this seems like it's going to solve the problem, except we're not sure whether 60, the 60-inch, there are 5 people who are 60 inches tall. Where should they go in this? So the rule that I came up with is that if you are at the very edge of a boundary, we put you in the next category. So 60 would be counted in this category. And the 60-inch people are not in this category. But this category would capture 59.99999 forever, would still be in this. So I don't have to sit there and write that. And this makes for a cleaner horizontal axis. And it looks like I did not make a graph for this. That would have been useful or interesting. Looks like I did not do that.